Hi, I'm Neha Bhimishetty from VIT Chennai. As a part of my internship at the Sparks Foundation, GRIP August 2021, in the domain of computer vision and Internet of Things, I have chosen the task 4, which is the detection of the face mask. The main abstract of the detection of face mask is due to the coronavirus, it has affected the world very seriously. One major protection method for people is just to wear masks in the public areas, and many public providers require customers to use the mask correctly for the safety purpose. So it is not easy to check each and everyone whether the person is wearing a mask or not. So here we are proposing a face mask recognizer, which where it recognizes the person whether the person is wearing a mask or not. And the main motivation of this is the main motivation of this is due to the spread of this novel coronavirus, wearing mask on the face has become more crucial. Still many people are unaware of the consequences of this taking coronavirus and wearing the mask for namesake, and some people take it for granted and most of the time refuse to wear the mask. It will affect not only the people who are not wearing them, also the healthy people. The spread of coronavirus would be faster than the velocity of air when people refuse to wear masks in crowded places like the airports, markets, railways, and so on. So, in order to alert them and to reduce the spread of this coronavirus, a real-time system is being designed which detects whether the people are wearing the mask or not, and it also detects the people who are wearing the mask improperly. Without a real-time system, the job to alert people would be hectic and time-consuming. So this system is designed using a deep learning model. Once the face of the people who are not wearing the mask is recognized using the face mask detection algorithm, we will be contacting the person and we'll be asking the person to wear the mask to make sure the life and the life of the surrounding people are on the safer side. Factories, industries, offices, and government agencies can also use the system at the entry gate to allow the people only if they wear a mask and to reduce the spread of the coronavirus. The main objectives are training them. The requirements of this project are Jupyter Notebook. It is an open source interactive web tool as a computational notebook which researchers can use to combine software code, computational output, explanatory text, and multimedia resources in a single document. It comes in an Anaconda software, which has other features too, like PyTorch, Spider, etc. Along with most of the data science related packages are installed. For our this project, I have we just require OpenCV, which is installed using the command pip installs OpenCV hyphen Python in Anaconda terminal. In this project, we'll be using the Keras deep learning library and we'll be running it on the top of the TensorFlow backend. The libraries and packages which we use for this are OpenCV, pip, NumPy, Keras, TensorFlow, MDCNN, Matplotlib, and pandas. For the coding, and we use the Sublime Text, which is a code editor with a Python application programming interface. It natively supports many programming languages and markup languages, and functions can be added using the plugins. And the hardware requirement is a CPU, Intel Core i5 6th generation processor or the higher one, and AMD equivalent processor, which will also be optimal. A RAM of 8 GB minimum or the 16 GB or higher is recommended. Graphics processors unit is an NVIDIA GeForce GTX 960 or higher. AMD GPUs are not able to perform deep learning regardless. The operating system may be the Ubuntu or the Microsoft Windows 10. The main modules of this project are the face detection, training, and the mask detection. In face detection, we will be inputting the pic with the pic face detector. The face will be detected for the pic. Here, our input is an image consisting of faces, and output will be the face highlighted with a rectangle, naming that wearing a mask and not wearing a mask with the accuracy of that. So here in this, we will give the access to webcam, reading images or video or and storing. So here our input is an image consisting of faces and the output is face highlighted with the rectangle. Training. So here we will be training the system with a database which has faces with mask and without the mask. With the use of the dataset, we can train a face mask classifier using the tensor flow. Here, so here the input is a database consisting of person wearing mask and not wearing mask, and the output will be the training of face mask classifier. And in the mask detection, first we'll be giving the face input. With face detection, the face will be detected and the system will apply a face mask classifier to each face RIO and then detect the face with a face mask or without a mask. If the person contains a mask, then it will show a rectangular box with a green color and it shows the detection percentage. If the person is not wearing a mask, then it will show the accuracy with the red color. Moving on to the final step, we do the following processes. That is, load the face mask classifier, detect faces in the image or web stream, video stream, extract each face ROI, apply face mask classifier to each face ROI, and detect whether face is wearing a mask, is with a mask or not. This is a sample output of image detection. This is the input image and the output is this. The person is not wearing a mask, so it shows with a red rectangular box with the accuracy detection percentage, and the person wearing a mask with green color and the percentage of the detection. As a person is not wearing a mask, it's with a red color and the accuracy. This is the output of the live processing. We will be inputting live video stream. When the person is wearing a mask, it shows with a green rectangular box and the detection percentage. And if the person is not wearing a mask, it shows the details of the person along with the name and the mobile number so that we can contact the person and ask them to wear the mask. I'll show the working of the project. Firstly, we need to go to the location where our code exists. This is the usage of the code. Yeah. So this is the output. The actual image of that is it's in the images folder. This is the actual input. We can also try for the other pictures. We can also try for the other pictures. Pick one.jpg. This is a JPEG file. So this is the output showing a green box, green label with the accuracy. This is the actual picture without any labels. This is with the labels. Now we'll see for the live processing. It says starting the video stream for the webcam. This will not work because the video is on in the meeting. So this wouldn't work. So this is why it's not working. So when we turn off the video and then try again, this should work now. Yeah, so this is the live streaming. The person is wearing a mask, so it's showing the accuracy of 100% of wearing a mask. If we remove the mask, it matches with the pictures in the database, and it shows the details of the person. It prints the details of the person here in the command prompt too. This is the output, and when it comes now in the to conclude this, one major protection method for people is just wearing a mask. So this will be helpful for any organizations to implement in their organizations. For future enhancement, we can use them in the traffic cameras and cinema halls, where it also is able to detect the people with and without the mask. Nowadays, many people service providers require these customers to use this service only if the mask is wearing properly. So it is not easy to check everyone whether the person is wearing a mask or not. So this face mask detector, where it detects if the particular person is wearing a mask or not, this system can therefore be useful in real-time applications where which require a face mask detection for safety purposes due to the outbreak of COVID-19. This project can be integrated with embedded systems for applications in airports or railways or offices, schools, and also the public places to ensure that the public safety guidelines are followed. Thank you.